PhonePe is trusted by 500 million users for UPI payments, grocery bills, rent, school fees, everything. Every payment must complete in under 2 seconds or the user abandons the transaction. To deliver this, PhonePe built a layered architecture where every component has a strict job. Route the VPA, validate the MPIN, debit the sender, credit the receiver, notify both. 8 minutes from now, you will understand the complete PhonePe system and be ready for any interview question about it. 5 things. The UPI three-party model, PhonePe App, NPCI Switch, and the bank. The 5-layer architecture you draw on any whiteboard. The end-to-end payment flow from VPA resolution through dual leg confirmation. The storage choice at each layer. And why, and the interview framework for design PhonePe in 45 minutes. Let us go. The UPI ecosystem. The payer uses the PhonePe app. The pay can be on any UPI enabled app, GPay, Paytm, a bank's own app. It does not matter. UPI is interoperable. All apps connect to the same NPCI switch. This is one of UPI's defining design decisions, one rail, all apps. The payer's payment request enters through the API gateway, PhonePe's single entry point. The API gateway checks the login token and routes to the payment service. The payment service is the brain. It resolves the VPA, validates the MPIN, runs fraud checks, and orchestrates the NPCI call. The payment service resolves the payee's VPA, the virtual payment address. Like Rajesh Oxby, it checks Redis first. If the VPA to account mapping is cached, it returns in under 1 millisecond. On a cache miss, it queries the NPCI VPA registry. The cache hit rate is above 80% because most payments go to the same set of frequent payees. The payment service sends the payment request to NPCI through the NPCI connector. NPCI is the central switch. It routes the debit instruction to the payer's bank and the credit instruction to the payee's bank. This is the dual leg transaction. Debit and credit are separate bank operations, coordinated by NPCI. NPCI instructs both banks simultaneously. The payer's bank debits the amount from the payer's account. The payee's bank credits the amount to the payee's account. If the debit succeeds but the credit fails, debit without credit, PhonePe's reconciliation service must detect and reverse this within 24 hours. This is the most critical failure scenario in UPI. The payment service writes every transaction to PostgreSQL, the permanent ledger. The record includes the idempotency key, payer VPA, payee amount, status, and timestamp. PostgreSQL is ACID compliant. Every write either fully commits or fully rolls back. No partial records. This is the audit trail that regulators require. You enter the payee VPA amount and MPIN. PhonePe hashes the MPIN client side. The payment request with hashed MPIN, VPA, and amount is sent to the API gateway over HTTPS. Payment service resolves the payee VPA. Redis cache checked first. If hit, account number returned in under 1 millisecond. Cache misroutes to NPCI VPA registry. Payment service calls NPCI connector with the payment details. NPCI connector formats the request in UPI protocol and sends it to NPCI Switch. NPCI routes the debit instruction to the payer's bank. Bank validates MPN and debits the account. Returns success or failure to NPCI. Payment service writes the transaction to PostgreSQL with status processing. If both legs succeed, status updated to success. Idempotency key prevents duplicate writes on retry. API gateway returns the payment status to the payer app. Push notification sent. Transaction appears in the app. Total time target under 2 seconds. Redis serves 3 roles in PhonePe. First, VPA resolution cache. VPA to account mapping, cached with a 1-hour time to live. Second, OTP store, generated OTP stored with a 5-minute time to live in Redis, checked on MPN validation. Third, rate limit counters, sliding window counters for per user request throttling. All three require sub-millisecond latency. Redis is the only viable choice. PostgreSQL is the permanent ledger. Every transaction, every user account, every VPA registration is stored here. PostgreSQL's ACID guarantees mean no transaction is lost even under server failure. The transaction table is sharded by user ID to distribute load. Double entry accounting, debit and credit as separate rows in the same atomic transaction ensures the ledger always balances. NPCI requires every UPI transaction to be logged with immutable audit records for regulatory compliance. PhonePe ships daily transaction batches to NPCI's audit store. This is also used for T+1 reconciliation, matching PhonePe's records against the bank settlement files to detect debit without credit failures. Full PhonePe payment flow, all components visible. Hop 1, payer enters VPA, amount MPIN, app hashes MPIN, sends to API gateway over HTTPS. Hop 2, API gateway validates auth token and routes to payment service. Hop 3, payment service resolves Payee VPA from Redis cache under 1 millisecond. Hop 4, payment service calls NPCI connector. NPCI routes debit to payer bank, credit to payee bank. Hop 5, transaction written to PostgreSQL with idempotency key, status processing success. Hop 6, API gateway confirms payment to payer app, push notification sent under 2 seconds total. 5 phases. Requirements: peer-to-peer payments via VPA, merchant QR payments, 2-second latency SLA, MPIN authentication, and offline fallback to SMS for OTP scale. 500 million users, 100 million transactions per day, 1200 transactions per second at peak. NPCI throttles at around 2000 TPS total across all payment apps. High level design: draw the UPI three-party model and trace one payment. Deep dive: the interviewer usually picks idempotency or debit without credit failure, no both in depth. Trade-offs: PostgreSQL ACID versus NoSQL eventual consistency for the ledger. And what happens when the bank API times out? UPI three-party model, PhonePe App, NPCI Switch, and the banks. 5 layers: client app, API gateway, payment service, NPCI connector, and storage. Redis for VPA resolution under 1 millisecond. PostgreSQL ACID ledger for permanence. Dual leg NPCI transaction, debit and credit as separate bank operations. Idempotency keys to survive retries safely. You can now draw this in 3 minutes on any whiteboard. Next video, the UPI payment flow in depth. VPA resolution step by step. How MPIN is validated without PhonePe servers ever seeing your PIN. NPCI switch routing between banks. The dual leg debit plus credit transaction, and the debit without credit failure scenario that haunts every UPI payment system. 8 minutes. Subscribe to ByteLearn for one PhonePe system design concept per week. Under 8 minutes. Interview ready. Hit the bell. See you Monday. Question: what edge case would you test for in this architecture? Drop your thoughts in the comments.